Voice of Industry.
Voice of Industries.
Thomas, welcome to Voice of Industries. Today we will discuss about digitalization in process manufacturing industries and more particularly on key success factors when it comes to do projects around digitalization, and also we try to look at it from the CIO perspective. So first, could you introduce yourself and your activity at ARC?
Sure, Mathieu. My pleasure being here. So my name is Thomas Menze and I'm consultant at ARC. Let's explain ARC for a moment. So ARC is an abbreviation that stands for Automation Research Company. So we are doing really market research in the industrial area, and our core competence and focus are the automation systems. We are doing this for more than 30 years, and that means we have a good insight into long-lasting trends, and this includes digitalization as well. So my personal focus is really process automation, and I'm supporting many initiatives regarding digital transformation of the industry. So that's me, Mathieu.
Thanks. So today we talk about digitization of industrial operations. To what we see, digitization projects seem to be really challenging for IT departments. And what I would like to start is to discuss about the risk and the different type of risk we see for this type of project. I know it's not so optimistic to start by talking about risk, but it seems that many companies learn the hard way that digitization is not an easy goal to achieve. Is that right? And what is your vision and what do you see based on your experience on this topic?
So you are definitely right, and your summary is correct. And let's start with the beginning. And you said already the IT department and the CIO, which is normally the manager of this department, they underestimate digitalization of the industry because, and that is simple to answer, the transformation in IT and the transformation in OT stands for operational technology, this is the automation part of the industry, are completely different. So some of these CIOs, they start the process based on their IT knowledge, and then they get bad surprises if they're trying to conduct this kind of methodology to the OT world. Because the IT experts, the team members of the CIO, are often only a little familiar really with production processes. For example, you cannot simply stop a production process, do a patch management on a certain software piece and then restart. It is not as easy. Simple things, but these kind of team members are really surprised what happened. And then the environmental condition on the OT side are completely different compared to IT. In IT, everything is in clean data centers, very structured, well documented. In the OT side, you have sometimes plants who are lasting for 20, 25 or even 30 years with outdated automation equipment. And if you start transforming that in a new way, then you really have no access to the required documentation. Sometimes you simply don't know what's really built in these kind of OT infrastructure. And then, of course, the interfaces in the OT world are completely different to the IT environment. In IT, everything is based on Ethernet physical layer and the protocols above that. In OT, you have really sometimes analog signals. You have 0 to 10 volt or you have 4 to 20 milliampere. So this is a complete different world. And if you try to get access to these kind of process values, process data, you have to conduct completely different methodology. And then last but not least, in the IT world, if something goes wrong, you can simply restart. That is impossible in OT. Imagine you have a production for a refinery. Mm-hmm. If you restart the refinery, this will end up in a 2 weeks break. So it is better to think before you act. So not joking here, but really the OT requirements, the OT environment and the OT specialities are completely different to IT. And that is in many cases the reason why the IT teams really fails to get the digitalization done in the proposed timeline.
Okay, clear. Based on your experience and feedback you get from industrial CIOs, what are the 3 or 4 most important risks that can derail such project? And I think you already talked about more technical risk, but I can imagine there is other kind of risk like organizational or even human risk in terms of management and change management. So could you elaborate on the 3-4 main risks you identified on the market?
The highest risk is definitely underestimated the required personnel, the required staff to do the transformation, because there's always a timeline in the background. And normally you talk to your IT team and you say, yeah, this kind of machinery in the OT area needs to be digitalized. And we have to finish it by end of the week, because then the machine is maybe needed again and will restart. And then you realize by end of this week, not even half of the automation system is being digitalized, because you're unexperienced how long this take, due to the facts we said before, completely different interfaces, lack of documentation and this kind of stuff. So that is the second thing that brings us to the time schedules. They cannot be met, because you have so many things to do and it's hard to coordinate. And if the time schedule cannot be met, then the cost is normally out of control. So for a successful integration, the involved cost is very often completely underestimated. And the scalability, if you maybe transform 1 or 2 parts of the shop floor, that's fine. But then you realize, hey, I have to do much more. I have to maybe do 10 other areas as well. And that takes much longer than I expect. And then all these special requirements, and something it's really special, it's functional safety. Because some of these plants are really risky to the environment or risk to the workers. And you have to take specific actions to reduce these risks, and this is called functional safety. And if you do a digital transformation, this functional safety needs to be under control, and there are very strict guidelines how to do. And this needs all to be documented, and so on and so on. And to meet these functional safety requirements during the digital transformation, that is another area where you can fail. And these are the main risks I see here now.
Okay, if I understand well, it means that all these risks combined together can lead to a low adoption of this digital transformation by people in the plant. Let's start with this topic. It seems that if you want to achieve a return on investment, you need to have adoption and to overcome the risk you mentioned. For you, what are the levers to reach a widespread adoption, either in terms of variety of business cases than in terms of number of people empowered by digitization?
I think that is really a complex question, and I can answer only in general, because it is different for every plant. But I think the most important thing is access to data, and data needs to be exchangeable, and you need access to real-time data. That is the first thing you really have to consider how to do so. How do I get really access to the data subsets in different production environments? And this is the only way how to really compare the production efficiency. Imagine you have production A and production B, and you want to compare the effectiveness of these two sites. You have to really compare the production data, and you need real-time access. And again, these two production plants, they can be maybe 5,000 kilometers away from each other, and you have to have a system in place which can which can establish that. Then, of course, if you're scaling up, you automatically have to think in the direction of cloud-based systems, because with cloud-based systems, you have the flexibility to need to scale up and maybe add additional functionality in the background without disturbing the main function of your system. And at the same time, every production process is unique, and sometimes there is a certain level of core competency in the production process. That means you need an app which is widely adaptable and free configurable to really meet the requirements of the specific production process.
To what I understand, scale-up is also key to maximize the return on investment, particularly in a global multi-site organization. What are the ingredients to consider in order to enable and make possible this scale-up over the whole corporate organization?
Okay, yeah, I think we discussed partly these kind of answers, but again, for a successful scaling up, the IT team needs to understand what is the existing automation environment. So they really need to understand what kind of interfaces, what kind of data subsets are used in the automation area. Then, of course, they need to understand really the existing OT controllers and the production data inside these OT controllers. And if they are going to scaling up, they have to combine all these different subset of data sources. And then, of course, the availability of the whole system is important. That means you cannot simply stop the production plant, do the scale-up work, and then restart. Everything has to be done in parallel. That means there's a running production, and you have to trigger the scale-up process. And this needs to be considered. And again, it's not easy. Sometimes you have really strange time frames to work on this digitalization approach. It's sometimes at night or very early in the morning or whatever.
Okay. On this, if we can dig in a little bit on this scale-up aspects, one thing we can see is that data is not so easy to scale up, not necessarily because of the volume of the data, but because if you want to scale up and apply approaches or dashboards or models, etc., you need to have a comprehensive data model that is shared in the organization, and also tools that enables you to, I would say, cut and paste use cases you have developed on certain site to, how to say, widespread this use case around the organization. Do you have some insight on these aspects of the scale-up?
Yes, of course. And my advice here is really use proven in use methods. So don't reinvent the wheel. Don't start from scratch. First, look what is really proven in use. And there are a couple of concepts. For example, data exchange, OPC UA is an easy to use and easy to configure interface and structure, which makes data exchange easy and data can be scaled up. Then you have the NAMUR NOAA model, and NAMUR is the association of the chemical industry, and NOAA stands for NAMUR Open Architecture. And as we said, this open architecture allow the parallel use of process data in the automation system and IoT data. So this can be a structure which can be used to scale up the subset of data. Use as often as possible wireless communication, because sometimes it is impossible to have additional or spare wiring in certain areas. So using these kind of interfacing options. So that means the cloud infrastructure is the basic for data collection, hosting the business intelligence apps, and everything in the cloud can be scaled up easily, especially if we go back to compare production side A with production side B. Everything can handled via the cloud. And these are my recommendation. And maybe the most important thing is use experienced external experts to analyze, first of all, the assets needs to be digitalized and needs to be transferred before you are scaling up. You really have to know what's in the automation system, what is the objective we are trying to meet, and what kind of infrastructure is necessary to get real-time access to the required subset of data.
So clearly, let's go to the basics. Know what is in your system, know your data, structure them, and think about use cases and how you can create value within the organization.
I could not summarize better. I agree entirely.
We talk about scale up, but can we consider for a few minutes one other aspect, which is the project planning, overshooting, and uncontrolled costs? In my opinion, these two aspects are having common causes. First, do you agree with that? And what are your recommendations to reduce the risk on these two aspects?
Okay, risk reduction is really important because risk means increase of cost level, and we all try to avoid that because we are doing the digital transformation to be more efficient, to be more sustainable, and that means we are trying to avoid the cost level. But cost was not the question. I think it is really important to use proven in use methodology. You can look into the NAMUR NOAA example. This is a data structure that allows the use of existing process data and combine it with IoT data. And NAMUR NOAA, NAMUR is the Association of the Chemical Industry, and NOAA stands for NAMUR Open Architecture, and they give you really guidelines to do the transformation up to modular production systems. So first recommendation is that. Second recommendation is really use standardized interfaces to exchange process data. OPCUR could be a platform which is helpful because it's a standardized platform for data exchange. And then of course, if you have sometimes issues with parallel cabling and wiring, use wireless communication as much as possible because that is helpful and reduce the required documentation.
You mentioned risk around time schedule, around costs, but just to be sure, when we talk about risk on the overshooting the planning, it also means that this risk can impact your return on investment because you will have benefits from this project much later than expected. And maybe in terms of competitiveness on the market, it's an issue. Is this
that is absolutely true. And I give you a clear example. Looking back, let's say, in 2020, so 3 years ago, we had the pandemic. And everybody discussed vaccines against the pandemic. And it was required that the time to market for the vaccine was done in real time. So there was no delay really accepted. And now imagine if you do a digital transformation process to reconfigure your production setup for the production of this special vaccine. And if your transformation process fails, that means you cannot meet these time to market requirements, then the company will lose the complete momentum. Maybe another company will be in the market and your competitiveness is completely gone. This is one classical example how not to do digital transformation.
Yeah, it's a good example, and I totally agree. We saw exactly the same kind of situation with industrial. We are very happy to have a cloud-based solution when the pandemic came because their engineers were able to keep supporting the plant even though they were locked down at home, and they were able to keep an eye on the production and continue to do their job because they went through this digitization process before the pandemic.
Yeah, and you see, this is really the beauty of being digitalized because your competitiveness is not only increased, it is even more flexible. So your production setup is much more flexible. And if, let's say, remote access is required, then you can easily establish that via cloud computing.
So thanks. I think we can conclude now based on your experience and particularly the experience gained in the past years. I think they can offer us some insights on what are these key success factors. In that matter, what are the three, I would say, takeaway recommendation you can give to a CIO to succeed in its project?
Okay, to keep it simple, and again, we all discussed these three aspects. The first one is use proven in use applications. So don't start reinventing everything on your own. Use proven in use wherever possible. Then again, as you already said, start with an analysis, start with a research on the as-is situation. You have to know what is really built into your automation system. And with that, we come to the prediction, how we do things better in future. Think about what kind of data is required to do this prediction. Really ask yourself, do I have enough data in my production environment, or do I need additional IoT data? If IoT is required, start early enough to establish, let's say, connectivity to this IoT data pool. Then combine the two worlds, process data and IoT data, and use proven in use analytical software tools to predict how your production can be more efficient in future.
Great. Thank you very much, Thomas. You gave us many interesting insights to succeed in such kind of projects. Thank you.
Mathieu, thank you very much. It was a pleasure for me being here and having this discussion with you.
Thanks.